Hi. I had the pleasure of going to Germany last week, 10 days ago or so, beginning of August, to do some NERS measurements with the German biathlon national team, which was really interesting in itself. And one of the questions that I got from the performance diagnostic team was can I look at different metabolism substrates using the MOXIE? And so what they were talking about is, well, how does the MOXIE relate to RQ, sort of the respiratory quotient, which is how much oxygen is consumed and how much CO2 is produced. And this is used to look at the substrates you're using to produce energy. So if you have, it's 0.7 respiratory quotient, say you're using all fat. And the higher you go up, you move more and more towards a mix with carbohydrates, and at one being all carbohydrates. And they wanted to know if the MOXIE can help with understanding this, especially kind of in training, right? When they don't have the VO2 equipment where they could actually look at RQ or let's say RER. Now, to preface this, as I always say, if you want to know if you want to know RER or RQ, you should go measure RER, and you can do that. That's going to be the best way to figure out these kinds of what substrates you're using. With that being said, however, there is a relationship between your NERS data, your MOXIE data, your SmO2, and what's happening with RER. And that makes sense because with MOXIE, with NERS, we're looking at oxygen consumption and oxygen supply and demand. And that's part of what RER is. It's the oxygen that you're consuming related to the carbon dioxide that you're producing. It makes sense that there's going to be something there and that we may be able to look at some of those things. And it is like that. So if you're going to do some kind of RAM tests and things, and you look at what's happening to your RER and you look at what's happening to your NERS signal, they kind of mirror each other pretty good. Meaning that kind of like the more oxygen you're consuming at steeper rates, which means you're metabolizing a lot of oxygen. You're using a lot of that oxygen for aerobic glycolysis as well, which means you're also going to start producing more CO2. That those things are going to match up together. Which is nice because you kind of get the feeling that, okay, I can do at least some kind of prediction, some kind of likeliness of where am I in my metabolism substrates by looking at your SmO2 data. So what is very likely is that if you're training at a given intensity and your SmO2 values are fairly stable at rather high values, so you don't want to be pushing real low values, it's the likeliness there that you're going to have a low RQ, that you are going to have a higher fat metabolism than if you have declining SmO2 curves to low values. Now, there might be a little bit of a question as well, but if I have slower values, it means I'm consuming more oxygen. That's true, but it also means your metabolism is moving much faster, which means you're likely also producing a lot more CO2. That's one point. The second point would be that if in studies where you give someone additional oxygen, so go hyperoxic, you actually decrease RER for given performances. You decrease the rate of lactate production, which indirectly looks at is basically you slow down the rate of glycolysis, and you're using more fat to produce ATP, which is what the RER would be telling us. So if you have high amounts of oxygen availability, it seems to make you more fat metabolic. So that goes also into this argument that the likeliness that if you have lots of oxygen availability, you are more likely to have a lower RER, so you're metabolizing more fat rather than carbohydrates, which is also what happens if hyperoxic air, people's SmO2 values stay higher. And again, they're going to be metabolizing more fat. So all of these things kind of come together that you're not going to know for sure. Again, if you want to know for sure, you better use your VO2 machine and actually measure RER. But the likeliness is pretty high. So I do think that there's an application for NERs here and the SmO2 signal to help gauge what kind of metabolic substrates that you're using. You're not going to be sure, but the likeliness becomes much, much higher, which is really what a lot of the stuff we do with signals is we play with likeliness questions. We never know for sure, but we try to do our best to understand, and we use signals like NER signals to feel confidence to have confidence in the decisions that we're making. So I hope that helps. It was an interesting question coming along. I had spontaneously that exact same question from a colleague of mine last week, so I thought I'd kind of try to answer that all in this video. If you have any questions to that, please let me know. And if any other questions also, please let me know. I think I will leave it there. All right, bye-bye.